Hello, my name is Mario. Welcome to another video. In today's episode, I will share with you another tip for building microservices in Go, specifically containerization using Docker, how to build your image, how to use Docker Compose to run that image for local development, and how to push that image to Docker Hub. So what is Docker? Docker is a tool designed for making it easier to create, deploy, and run applications using containers. It's not only a tool, but it's a collection of different tools that allows you to create a package, an artifact that can contain the things that you're supposed to be deploying. Think of what we're doing right now. We're building a web service that happens to be a binary that may include some artifacts, or may include, well, in this case, it's not including them because it's already embedded using the 1.16 embed feature. But think that it may require some certificates, for example. Things like that. So basically what is Docker supposed to be doing is wrapping all of those dependencies into one single artifact that can be shared between different services. Now, at the moment, the most popular registries, or the way that you can push your images to, which is what the Docker calls these artifacts, are Docker Hub, Amazon Elastic Container Registry, or ECR, and Google Cloud Container Registry. The idea of those services, and you can literally run your own if you want to, like on your on-premise. But the idea of having this is that these are sort of like third-party providers that allow you to host your own images, so you can refer to them when you're running either your continuous development or your continuous integration things, or maybe when you're running your actual services that happen to be dependent on Docker images. Now, the cool thing about Docker is that because it's a self-contained artifact, you can use this tool called Kubernetes, and it's literally to allow you to run orchestration and an easier way to configure all the different things that you can do with the services that you can define using the different images. At the moment, the most popular ones for Kubernetes, or sort of like not Kubernetes only, but also for a way to have some sort of like a images and containers and a way to have those auto balance, is Google GKE, which is Google Kubernetes Engine, ECS, which is Amazon Elastic Container Service, and EKS, which is Amazon Kubernetes Service. And obviously, because this Kubernetes is an open source project, you can run those locally, not locally, on premise if you want to. Now, I will give you just a sort of like a quick introduction to Docker. And the way to use Docker, first of all, you need to install it. And if you haven't used Docker before, I will put a link in the description. The way it works is, it's not that difficult as soon as you kind of get an idea of what it's supposed to be doing. Just think of a container that is wrapping everything that you need for running your application. Okay, artifacts, dependencies, binaries, assets, all those kind of things. Now, above that, you will be adding things that that happen to be using that artifact, like for example, configuration about how much CPU is using, how much memory, perhaps what is the network configuration that is supposed to be using, the auto balancing, how much instances they're supposed to be running, what is the security that you're going to be applying to those containers, those kind of things. The way it works is that after you download depending on the platform that you're using, it will give you different commands. So I've been using a few different images during the previous videos. I've been showing you how to run Postgres or Vault or Jaeger or Prometheus, and even Redis and Memcached. So the idea is that you can run a container that it can be any version of any service or any program that you want to have, and then after a while, if you want to get rid of it, you just literally remove it. There is an option of actually saving the actual volume or the data that is supposed to be saving or interacting with. But the whole point of defining containers is that because it's super easy to create those containers, you can literally have the opportunity to run multiple different servers of different versions of those servers at the same time using different ports and whatnot. So that's one of the things that I do like about Docker. And Docker is not the only one, the first one doing this or sort of handling containers or taking care of containers, but this is the first tool that made it sort of popular and made it easy for everybody to use it. So that's why it became such an important project that nowadays all the cloud providers use for sort of orchestrating and creating, depending on the traffic and those configurations, creating different services, auto scaling and those kind of things. So understanding Docker just literally, in my opinion, requires probably a few different commands or a few different options, which will be creating an image, running an image, understanding what is a Docker, understanding what is a container, and understanding exactly what is an image. So the idea of an image is think of an artifact. So if I do the command docker images, after you install this, you will notice that I have a few different images right here locally on my computer, on my machine. And if I do like a PS, which will be equivalent to do like a PS of your local command if you're using Unix, or in this case I'm using Mac OS, but if you use Linux, it will be sort of the same, is that all the processes that are running, and it's sort of the same, it's equivalent to that sort of command. So you have images that are representing sort of programs, but really they are not programs, they are sort of artifacts that represent a collection of programs that run in Docker, that are wrapped around the Docker container. And then the container itself, like I said, is an artifact, and the container is the actual thing that is running, and the image is the actual artifact. So when you're running different containers, like for example, I have a few containers stop right here, which I'm running Postgres, I'm running another Postgres right here, and I'm running a Redis, right? So the idea is that you can, because you have the flexibility of running different services, you can run those services or those servers, and as many as you want, as many as you need. And the cool thing is that because you can define multiple ports and you can stop them as you need, you can literally use multiple versions of the same kind of service. At the moment I'm using 12.5 for Postgres, but imagine if I'm using 11 or maybe 9 or those kind of things. I don't really have to compile all of that locally for running that service. I mean, I know that you can do it, you can specify different paths, and you can do a different LD flags and those kind of things. I mean, there is an option to do that locally already. But the cool thing that this is, when you're using Docker, things are much more easier. There is a flexibility when you're trying to use Docker. Now, I'm giving you all of this because what I want to be doing next is I'm going to be discussing with you how the actual Docker image, or rather the Docker file, was built. And this is one of the cool things about Docker, is that it allows you to specify different layers. And the way it works is that depending on how you write your Docker file rather, it will perform in different ways. It's sort of like each one of these lines, it indicates sort of like a layer, and it works or is caching each one of the layers. So if you make a change and the previous layers didn't change, and you had those layers locally on your system, those layers will not be run one more time. It's sort of like a caching mechanism that Docker has, and it allows you to speed up the build of those images. Specifically, what I'm trying to do here for this project is to create a small artifact, a small image that happens to contain only 2 files and all the files that are needed for using those 2 files. Specifically, what I'm trying to do here, I'm building and installing, well, in this case I'm compiling the migrate binary for running the migrations, and I'm compiling the rest server binary for running the HTTP server, as well as copying over to the final image the example file for the environment variables configuration, and the DB folder, which includes all the DB migrations. The idea of this is that as soon as I have this available, I can run this on any machine that I want to run it that happens to be supporting Docker. So the cool thing besides all of that is that everything is self-contained. Okay, now if I look at the Docker Compose, and the Docker Compose is sort of a way to orchestrate different containers that happen to be referring to different images, and they allow you to run all of them at the same time, sort of like a self-contained collection of Docker containers and programs that happen to be depending on each other if needed. And the cool thing about this is that the way it's structured at the moment and the way the configuration exists is that you can specify, hey, I have this service called API that depends on the following 4 services. And I've been covering all of this like Prometheus, Vault, Postgres, and Jaeger in the previous episodes, and you can feel free to check out all of that. The only problem with the way Docker Compose works is that when I'm running Docker Compose, if I do an up, although I define depends on right here, it actually doesn't really wait for the Docker to be healthy, and the reason being is that healthy depends absolutely on the actual container itself. There is no standardization of what being healthy means. For a database, it could be like, okay, it's listening on port, I don't know, 5432, or maybe MySQL is 3306, or maybe Kafka is something else, and this is specified in the documentation for Docker, and it's something that you need to consider. And I'm calling that out because if you notice right here, what happened is that because it takes some time to run my database, my API server or my HTTP server is going to fail because the actual database is not ready yet. So that's why there is a way to somehow interact with this group of containers, of this group of services, while you're working or you're trying to run them. So that's why I'm at the same time I'm saying, you know what, let me try to run API one more time. So I'm calling this out again. I'm repeating what I said just now, but I'm saying this again because what is happening is that Docker specifically knows this, and there is no way around it unless you specify or you add a program that is actually listening for those events or for those servers that need to wait or need to run before the ones that depend on are available. So if I go back to my service, you will notice that if I run to my everything is available, everything is running. So I have my REST server, it's running Jaeger, Postgres, Prometheus, and Vault. So everything is supposed to be running. If I copy this over and if I go to my server, you will notice that it's failing, obviously, because that's not the path. But if you remember when we were doing the Swagger UI video, everything is here. Okay, so this is a problem. I made a mistake with the actual address. It should be 127.0.0.1 because the way it's configured in the OpenAPI configuration is actually referring to this address, not the 1.0.0.0, so on and so forth. So what is happening right here is that, again, remember that we are sort of using Docker containers for all of this. Okay, so this is self-contained. None of this existed before we actually run the Docker Compose up command. So everything is brand new. If I try to create a new record, what is going to happen is that it's going to fail, and it's going to fail because the actual table does not exist. Remember, when we're running this locally, what is happening is that we run the Docker, the PostgreSQL server, we run the migrations, we run the Vault and Prometheus and Jaeger, everything manually. But when we're using Docker Compose, none of that is explicitly indicated unless we tell it to do it. So the way to fix it, and I have it in the actual Docker Compose, is that I have these instructions that it literally does is it runs the API, which is this service, but instead of using the command that I have right here, I'm actually using the migrate command. That if you were curious and you were paying attention, is the one that actually I copied that binary over from the one above it. So I'm actually in this actual artifact, I'm including the REST server, I'm including the migrate, and I'm including the migration as well as the example, the environment example for configuration values. So all of that is just to sort of like make software development, or rather the testing, a little bit easier. So if I run this again, it will try to run the migrations, and it did. It succeeded. So if I go back to my create and execute the same, you will notice that it allows you to create the post that it was working before. So all of this is to confirm that everything is working as expected, and we are okay with that. Okay, so Now that we know that all the images are correctly created, we know that the Docker Compose seems to be working, and the next step will be to define, have a way to publish all this data into a registry. And this registry could be either what I mentioned before, either Docker Hub, or maybe Google Docker registry, or maybe Amazon container registry. It's sort of like a way to share all the images that we have with our users. Either could be like maybe a CI/CD pipeline that we have, or maybe it's the actual services that we run on production, or maybe on different environments. And for doing that, what I'm going to be doing this time, I'm going to be using Docker Hub. The way Docker Hub works is that you can log in and you can connect your GitHub account to this specific project, and you can create a repository. The way it works is that, let's say I want to do microservice example, and then I already linked my GitHub account to my Docker Hub account, what I'm going to be creating. And after I'm doing this, the way it's going to be working is that if I go to builds, automated builds, and then link to GitHub, I can actually specify the project that I want to link it to. So if I go to do microservice example, I can actually specify, what branch I want to use. I want to use the branch main. And if you look at my path, I have it under the REST server. So it will be build REST server Docker file. So you can put Docker tag will be latest, Docker file, build REST server Docker file. And I can do save and build. So if I go and push this one, if I go to main and then rebase, and then I push this one, what is going to happen is that it's going to actually trigger is already queued up, so it's going to wait a little bit, and then it's going to continue doing its thing. It takes about, the first time, it usually takes about maybe 6 to 10 minutes to complete, so we're going to be here for a while. So one thing I noticed is because I added the repository before pushing the new branch to main, it actually triggered two jobs. So I canceled the other one before, but it seems to be trying to build it. It's still trying to build it, but anyways, it doesn't matter. What is going to happen here is that, again, all of these will be, the link will be in the description, so you can check it out. What is going to happen is that it's going to clone the repository, it's going to build the thing, and it's going to push the image to this Docker Hub repository. Now, all of this is just a way to give you what could happen when you work on a project, whatever that is. So if you're working on microservices on a new project, it's most likely we're going to be using, again, it's not all the time, it doesn't happen all the time, but it's most likely we're going to be defining we're going to be using a cloud provider, either Amazon, Google, or Azure, and it's most likely that we're going to be using a service that happens to be requiring us to define Docker images. So that's why it's really important to understand how these Docker images things work, and I will give you more links in the description so you can check them out. And hopefully, this was sort of like a crash course of how to use Docker images, the way that you can connect those to Docker Compose for running local development, and also how you can push those Docker images to a service that you can use for CI/CD, or maybe for running or pulling the images for running them on actual production services. Hopefully that makes sense, and if not, just let me know. I would like to expand more of these topics in the near future if you have any more questions. My name is Mario, and I will talk to you next time. Until then, take care. See you.